Hello, good morning.
Good morning.
Good morning.
Hello. Good morning. Today we're going to continue on. Hopefully everyone was able to install Visual Studio okay. If not, while we're doing this presentation, go ahead and do the install steps and then catch up as soon as you can. First of all, can everyone hear me and can everyone see my screen?
Yes, sir.
Yes.
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 And okay, so today we're going to continue on with actually doing a little bit of coding. And note that Monday is Labor Day, so the school is closed, and we'll pick up back on Wednesday. There will be a quiz in class, but it'll be basically just doing Hello World. So I'm going to and it's mostly for me just to confirm that everyone was able to install Visual Studio okay, and that there aren't any issues there. Let me restart my Visual Studio so I'm at the same time. So let's all open up Visual Studio. And sometimes it takes a little bit of time. And when it opens up, it'll generally open up to this dialog screen. And what we'll be using is down here on the right, create a new project. If you already have a project that's been created, you can actually open it, use open a local folder to open it as well, or open a project solution will actually work as well. And sometimes if you've been working on something quite a bit, it'll list the programs you've been working on over on the left side, so you can open them up there. So I'm going to create a new project, and I'm going to pause. And there's a hand raising icon that you can like I've just raised my hand. If you can click that when you're ready to move forward and you're at the same step I am. This way I can keep everyone in sync with the demo. So open up Visual Studio and get to this point. And I know one of the challenges is some of you, if you have one screen, you're going to be flipping back and forth between what you're going to be typing in. You can put the screen side by side. It does make Visual Studio really small. So it's just kind of the reality of the structure of what we have to do. But I think it's useful to type as we go. So just waiting on a few more.
Mr. Gardner?
Yes.
Like my laptop broke down this week and I barely got a new one, so I'm like really behind, like barely installing Visual Studios.
Okay, no worries. Go ahead and keep working on your laptop and listen. This is being recorded. What I'd recommend doing then is afterwards go back through and run through what we do in class with your machine once you have it up and running, and then let me know if you have any issues or any questions.
Yeah, like you uploaded the video to Teams, right? The first one.
Oh yeah, thank you for reminding me. There's some technical difficulty with that. For some reason, it didn't go up to Teams. I don't think, unless it finally went over last night. So what I've done is, if you go to Learning Modules, and I might try to keep doing this. It takes quite a bit of time for me to do it this way, but right where the PowerPoint is for the presentation, I'm going to try to upload I have to take the presentation, download it, and then upload it through my slow connection up to YouTube, and then I can put an iframe in to where I have the PowerPoint. That way you can find them right here. So when I record the presentation, it should go directly to Teams, but I will try to also post them here right in the learning module, so you can just go there, and that will help you find them later on when you're looking back for some material. Does that make sense?
Yeah, thank you. I would also like to tell you that like it does show up there, but when you try to view it or download it, it won't work.
Oh,
Like
in
on
Teams?
Yeah.
Yeah, I think there's something that I don't know why, because in the summer, it worked just fine and it just uploaded there. So maybe yesterday it just had a problem, or just the sheer number of people that were on at the same time. I don't know. So I'm going to try to do this just as a backup to make sure, and plus that will put it in my shell, so it'll make it easier for you to find.
Okay. Thank you, Mr. Gardner, and again, I'm sorry for this delay on my part.
Oh, no worries. Just get things loaded, and we'll get moving forward with it.
Okay. Thank you.
Mr. Gardner,
Yes.
I wasn't able to download it. I ran into some troubles with Boot Camp, but I'm
Okay.
gonna order a computer to the school to see if I could use a school computer.
Okay. I've had people have success with Boot Camp, so was it that Boot Camp wasn't working, or that you couldn't get Windows up and running?
It just took a little bit because it's new to me to use Boot Camp.
Yeah.
So I'm kind of just going step by step with it. I didn't finish completing it, but as
Okay.
soon as I complete it, I'm going to be able to work through that. But I just was trying to find a quick solution.
Yeah. And then you can use the VDI too. Did we go over that? I think if you go to learning, it's a good point to mention that if you're trying to get things operating, you can go and install the VDI client. There's instructions here how to do it, and then you can connect up using that to a virtual machine at the school, and the school will have all the software loaded. So that's another option, especially if you're trying to get your machine, sorted out, and it's taking a little bit of time. You can keep working using that.
So the VDI, it already has the programs on.
Yes.
Okay, let me log into that real quick.
Yeah, it's like if you were at a lab computer, except that you're going to have an application, the Horizon View client, which will connect you up to it. Now, I've heard it's a little bit slow. It's not ideal necessarily working through the network to a virtual machine that's on a server, which has a bunch of people, but also on it. But I think it seems to work okay. So that's an option, and then it gives you time to kind of work on getting things sorted out.
Yeah, let me work on that today, and then I'll finish Boot Camp later today, and hopefully by next Wednesday I'll be able to have it all fixed.
Yeah, and if this initial stuff gets anybody kind of delayed getting started, let me know. I'll give extensions, to help you get started. I understand that sometimes our hardware issues, especially, since you can't just go to the school and work in the lab, makes things a little bit different. Okay, so I see most people seem to have it installed. I'm going to go to the next step. It's not, and so if you're still getting things sorted out, you can catch up to this. Basically, what we want is we're going to be programming using C++ console apps. And your screen may look a little different because I've been using mine for a while, so it's kind of reprioritizes things. One way to find it is up here. You have a choice of where you can pick the language. So I'm going to pick C++, and on the right, I'm going to pick console and platforms. I think I'm going to pick Windows, and you should see different options. You don't want empty project. There are certain things that we need preloaded. We want this one that says console app. So select console app and then click next. So I'll pause here before I click next to give people a chance to look at what I've selected, and then you can click on yours and it should go to the next step. So once I pick console app and then click next, it'll ask me to make a new project, and I'm just going to put in Hello World as the project name. And it's going to store it in a default location. That default location is generally your home folder, source, and repos. You can leave it there. You could also click on the ellipsis here and pick a different folder. Source repos is as good a place as any to put it your project. Just remember that that's where it's ending up. And, of course, if you couldn't remember, you could start a new project and you'd see that directory and you could find it there. So that's the directory that it's going to store Hello World in. And so once you have that, click Create. And let me go ahead.
Sorry. If we have an external hard drive, can we put it there?
Yes, you can put it there. You're going to want to make sure it stays connected when you do that. Yeah, that should work okay.
Okay. Thank you.
Okay. And then let me remind everyone, as I go through these demos, it's, I look out at my students and they're looking up at me when they're done. And then I know that I can go on to the next step. I don't have that luxury here. And I could ask every single step for you to, raise a hand or to say that you're complete, or, ask everyone to poll everyone after every step. But that's kind of impractical. So what I'm going to ask you to do is, if you're not ready to move forward, I'm going to say at the end of each, periodically, as if everyone's ready to move forward. If you're not ready at that point, just tell me, hey, I need a little bit more time, and then I'll pause for a little bit. I do have to try to get through these, within a reasonable amount of time. So if you get stuck, these are being recorded, and you can go back and follow up. And a lot of my demos will have the instructions available to you as well in Word documents that we'll download. So as we go through this, though, feel free to ask me to slow down or stop or hold on, or ask a question if you get stuck. And most likely someone else is getting stuck too, so that will help them out as well. Okay, so I'm going to go ahead. If no one has any problems, I'm going to go ahead and move on and create. And oh, I already have another Hello World. It's because I've made another. I'm going to put 2 on mine. And so when you hit create, it's going to create your project. What it's doing is it's creating a directory structure. It's actually a pretty shallow one, but it's creating some folders for you to put your programs in. And I've noticed that the first time you start running Visual Studio, it's a little slower, and then as you start creating projects later on in the day, it goes a little faster. Maybe Visual Studio needs its coffee in the morning too. Okay. So now what we have is we have our Hello World application, and there's some instructions on there to get rid of this verbiage down at the bottom. Basically, this is giving you some hints on how to get started. And it says, to run your program, hit Control F5 or debug start. When this is debug start, it's talking about here. If you click this debug window, you can run your programs in two modes, either with debugging or without debugging. Initially, we're just going to run without debugging. And if you hit run without debugging, it'll actually do all those steps that we talked about last time as far as compile, or that it'll compile your code, and it will it will link your code, and then it will run it all in one step. So modern integrated development environments do all the build steps all for you. And you'll notice that then a console opens up and it says Hello World. If we look at our code, we can see we have standard out, cout, Hello World. So what I'm going to do is, and then you can read through this. You have the Solution Explorer window here. That's listing all your files. So this file, Hello World, is actually located here in this folder that says Source Files. If I close this, I can open it by double-clicking on CPP, and that's our actual program right here under Source Files. There's really nothing else in here. If you were to right-click your solution folder and open folder in File Explorer, what you would see is that this is actually, in File Explorer, this is what's up here. So we can see Hello World. We have, let me see if I can get to, here. Here's Hello World 2. This is the one that I created. And then down here, you notice that you have another directory called Hello World 2. This top Hello World 2 directory is the solution directory. And then you have a project directory down below it, this one right here, which is actually a child of the first Hello World 2 directory. It just happens that Visual Studio will name your project the same as the solution. Now, you can actually have multiple projects inside of a solution. We're only ever going to have the one project inside of here. When you turn things in, I'm going to be asking you to turn everything in from the solution, the top level solution folder. Sometimes people just hand in this lower one. I need the whole thing. Now, the other things that you have in here is you have a debug folder, and this debug folder is actually where your program ends up. So this Hello World program is, if you look in there, you'll see there's a .exe. If I double click on that, it actually runs, but because I don't have anything holding this window open, you see it kind of flash, it runs and closes right away. I can show you how to hold that open, but basically this is the executable. And then inside the project folder, Hello World 2.cpp, that's actually your source code right here. And then you have these project folders and these other folders, which you don't see here, which are used to manage the program. This debug folder here is also used in building your object code. In fact, you see Hello World 2.obj. That's the object file, the intermediate object file that's created, that then is linked with all the libraries to create the exe that's up here in the solutions debug folder. So the compilation process is this project file is used to take your source code, build this object file. This object file then is combined with all the libraries are referenced, like here it says include IOStream, to create the executable here, which is actually the program that runs. So this folder structure is kind of a reflection of that. So let's do some modification on this. We're going to clean this up a little bit. Oh, and by the way, to open up a project again, I'm going to open folder and file explorer, and I'm going to close my solution. I can double click on the SLN file, the .sln file, and that will open my project up again. Unfortunately, it opened up in preview, but that's okay. I've got 2 versions of Visual Studio on. So are there any questions while mine is opening back up?
I have a quick question. I was able to go through the VDI and
Mhm.
open up Home Visual, and I created a new project, and you said to enter Hello World at the top.
Yes.
Okay.
Hopefully I didn't mess up my whole program. Okay, we're back. So I'm going to delete all this this stuff here, and then I'm going to ask that when you create a program, you put in the comments like this. So you're going to want to put a comment header at the top of every file you create or touch or modify in from here on out whenever you make a program. It's kind of like your engineering stamp. It's kind of the thing that says this is I created this, and put your contact information, and then also explains what this program is for. And then the other thing that we do is we add using namespace standard, and that allows us to get rid of this nomenclature. We have to put standard : in front of everything. It just makes it a little easier to see the code. And then generally I put in return 0 at the end because main is an integer. You don't really have to these days, but this just means result okay. It tells the operating system that it came back okay. You can do single line comments like that, or you can do multi-line comments with if you put a slash asterisk at the beginning and an asterisk slash at the end, that allows you to do multi-line comments like this. And that way you don't have to use double slash everywhere. So this terminates the comment and that starts the comment. And the thing about comments are, it just basically tells the compiler, hey, don't try to compile this. These are just comments I'm putting into my code. So that's generally how we will make our programs look in this course. And, you know, the reason why we have this is to be able to use cout down here. If I didn't have this include, then notice it doesn't know what cout is, and we get an error. We get these red squiggles and it says, hey, I don't know what cout is. That's because we didn't include the library. Similarly, if I didn't put using namespace, if I don't have standard : it says, hey, I don't know what cout is. It needs both the namespace and the library in order to find these commands. Most things that we use will be in the standard namespace, so we won't have to, we'll only have to do this once, but we'll include multiple libraries. Okay, so I'm going to move on. So if there are no questions on the hello world, I'm going to move on to presentation. By the way, what the quiz will be when we get back is basically, I'm just going to ask you to do a hello world like this and just put several comments in there, and there'll be some questions for you to answer in your cout. Now, the other thing to note is, note that we have these double quotes around this text. If I don't have those double quotes, what happens is it thinks that hello is a command, and it looks in its list of commands and says, I don't have a hello command, and so it gets confused. The double quotes around the cout are important because what they're doing is saying, hey, this is just a string of text that I want you to send to cout, which is a standard out. So these double quotes, basically, they encompass a chunk of text or a string. And so whenever you want to output something, you have to put these double quotes around the text you want to output.
Mr. Garner,
Yes.
what does the light bulb icon mean?
What's the what?
On the, there's a light bulb, like a light bulb icon.
Oh,
It's my,
in Visual Studio?
yes. What does that mean?
Where do you see a light bulb icon?
It's right after the numbers. I have it right on. I'm not sure if,
Huh.
oh, I see what it is. I think I know what it is.
Okay.
It's because I wrote the result okay, like you have it on the screen on 12.
Oh, like this?
So okay has a little, yeah, exactly.
Yeah, that's basically it's basically allowing you, giving you a little bit more detailed error message, and it also it tries to guess what the problem is and tries to solve the problem for you. Unfortunately, it's too far out for it to figure out what's going on here. So sometimes that can actually have the answer. A lot of times it doesn't, but it's basically showing you refactoring options and possible fixes. We'll find that so it tries to do the best it can. It's a computer program though, so it's not as flexible as we are, so it doesn't always understand what's going wrong. So programming fundamentals. So when we're solving a program, what we're really doing is we're creating something called an algorithm. And what an algorithm is independent of the actual syntax of the language, you know, how you actually have to write the language itself. An algorithm is a process or set of rules for following or solving a problem. Basically, if you think about it, if we were going to drive our car somewhere, we would get into our car, or we'd open the door, step into the car, close the door, put on our seatbelt, step on the clutch, put your key into the ignition, make sure it's in neutral, turn the key, put it in gear, you know, look behind, left and right, start releasing the clutch, start feeding in some gas, and then moving forward. So if you think about that step-by-step description of that process is an algorithm. Notice when I described that, none of that was really in any kind of code language or anything. So the steps to solve a problem are figuring out the steps to solve a problem are the first step in making your program. So let's say we wanted to figure out the surface area of a can. Well, how would we do that, you know, just normally? Well, what we would do is we would, I'd say, well, we could think of it as the area of the side plus the top area of the top and the area of the bottom. Well, the area of the side really is a rectangle if you think about it. If you were to cut this can apart, you would see that the sides are the, let's see, where can I, it's not going to give me a pen. Huh, interesting. It's the height is going to be one part of the area of this, and then I need the bottom, the width of the bottom, which is really going to be the perimeter. So if I can think of this circle here, this whole circle perimeter is how long this rectangle is from one corner to the other. Well, so that's the perimeter times the height is the area of this area, and the perimeter is going to be related to the radius of one of these circles. And the area of these two circles is basically pi r squared, which is a formula for the area of a circle. And so what we really need we figure out from doing this is, well, I need to know the radius of the circle and the height of the can. If I have those two things, I can figure out the total area of this by adding the area of the top plus the area of the bottom. Since those are the same, I can just figure out the area of the top and multiply it by 2, which is pi r squared, plus the height of the can, which is, you know, given, times 2 pi r. 2 pi r is a formula for the perimeter. So now that I have that, I can figure out that my algorithm was really ask the user for the radius, ask the user for the height, figure out the area of a top by multiplying those out, and then figure out the area of the sides. 2 times the top plus the side gives me the total area. So now I have my algorithm. I can lay that out in my code. And actually, I would typically what I do is I'll write that out as comments, and then we get the area of that that code. So the steps to programming this is understand the program, know what the program inputs are and how they come into the program, and understand what the problem is and the desired result. And then, once you've got that identified, we can then use that to lay out our problem and write our program. And so we'll do that. Now, you could at that point try to solve the whole thing all at once. What I'm going to recommend is that rather than trying to write the whole program from top to bottom and then run it, that we actually figure out that we write out our pseudocode. And so we might write our pseudocode out something like this. So we would do I usually would do something like this, like get, so output, the header, get user input for radius, get user input for height, calculate area of one circle, calculate area of sides, and then calculate total area, and then display result. So this is called pseudocode. We're not writing code, we're just using comments. And as we learned, the computer really just ignores comments. So right now we haven't done anything. If I run this right now, it's just going to say hello world. I haven't changed or done anything yet, but I've actually done most of the work in figuring out how to do this program, maybe already at this point. So I haven't changed anything yet. While we're here, can someone give me a recommendation how I could maybe output a header that says, welcome to my program, this calculates the area of a can? And so you don't have to type these all in, I'll just paste this into the comments. You can actually copy and paste those steps in if you don't want to type them all in. Well, at this point, we don't need to declare a variable yet. The header is just, say, how could we do that? Well, we actually have an example here. We can just use the same approach here. We can say, welcome to my program. It calculates area of a can. And then we put a \n to make sure there's a carriage return. And I don't need this anymore, so I'm going to get rid of that. And if I run that now, welcome to my program. It calculates the area of a can. Make sense?
Yes.
Yeah, so, and you can say display results is going to be something along those lines. So that's how we start. And then we actually did a first iteration. What we did is we wrote a little bit of the code and then we ran it right away. That's what you're going to want to do. You're not going to want to write the whole program all at once. You're going to want to break it up in pieces and then solve each of those pieces one at a time. That way you have a lot of simple problems rather than one complex problem, because it's not unusual for a beginner to spend hours writing a piece of code, never hit run, and then they hit run and it doesn't work, and then it's really hard to figure out what's going on. Let me ask you this. If I write 3 lines of code and it doesn't work, where's the problem?
It's only in 3 lines of code.
If I write 30 lines of code, where's the problem?
Within 30 lines of code.
Yeah. So if you write 3 lines of code, make sure it works. Write 3 lines of code, make sure it works. I guarantee you'll save a lot of time. So what we do is we write a little bit of code, we run it, we see if it works. If it fails, we fix it, and then we go back. And eventually, after doing that, you get the whole thing working. You're not done yet. At that point, then what you do is you need to evaluate that it works. Now, we initially, did the problem by hand to see how it works. When you do that, what you want to do is, that's called making a test case. You make the test case first, and then after you finish the program, you take your test case and you put it into your program and make sure it gets the right results. If it doesn't, well, now you got to go back through and try to figure out, why the results are off. Now, if you also, as you're doing your math, you're solving your problem, you figure out intermediate results. You can use those as you're writing your code. So you write your 5 lines of code, you have it display the intermediate result, and even if you wouldn't normally display that, go ahead and put a cout statement and display it and see if it's tracking along as you're building up your solution. By the time you get to this evaluation step for the whole piece of software, often by then you'll be succeeding. If you haven't been checking your intermediate results as you go, you may come up to here. And again, you're in that problem where, oh, it's not working. I've got to figure out in this whole thing where it's going wrong. At that point, a lot of times we're going to learn how to use debugging, which will allow you to step through the code and look at things as they go along. But if we were checking things as we go along, it'll be a lot easier. So let's look at the format of a C++ program. So one of the things to note is that C++ is case sensitive. Total, and total are separate things. They are not the same variables. C++ programs are, so you do have to pay very close attention to your capitalization. Yes, there is a need to put semicolons after every statement. That defines, that actually is how the compiler figures out that it's got a complete statement. So it reads everything into the semicolon and then compiles that line of code. Also, C++ programs are written inside of functions. We already wrote a function that main, the thing that says main, that's actually our first function. So main is a function. The way we know it's a function is it has open and close parentheses here. Sometimes functions will have parameters that we'll place inside of these. Main doesn't have any parameters, so we just put open and close parentheses. We still need that so that the compiler knows that this identifier is for a function. The things that are in blue and other colors, those are keywords. The things that are not keywords. So main is an identifier. It's a special one because that's the one that's going to look for first. Actually, in this one, the coloring is a little different. Let's see. How do they color it here? I'll take that back. Well, actually, it's using cout is an identifier for a function in the library. So yeah, in Visual Studio, it looks like they don't always color all of the keywords in blue. In any case, some of these things are keywords, some of these are identifiers. Main is an identifier. Cout is an identifier for a function or inside of IOStream, and in this case, so everything will be contained in, has to be inside of a function to operate in C#. So all of our statements are inside of functions, and you'll notice that there are these curly braces. We call those curly braces a block of code. So a function is really an identifier, parentheses, a return type. In this case, main returns an integer, and then in curly braces, a collection of statements that are executed by the compiler whenever this function is executed. The operating system is going to execute this main function, and when we start or run our program, it will do these steps. And if we ran that, as we saw, it said hello world. We saw that we can make comments. A single line comment is 2 double slashes. A multi-line comment can be done with an opening slash asterisk and a closing asterisk slash. The way the compiler looks at this is if it sees a double slash, it ignores everything all the way to the end of the line and then starts compiling on the next line. With a backslash asterisk, it ignores everything that follows that until it sees an asterisk and a slash. Your comments should explain your thought process and your logic. So here you can see the programmer is saying, I want this library for screen and keyboard I/O. That's actually a decent comment. If you're just repeating what the command says, you don't really need that, because I mean, I know this is including the IOStream library. The question is, why am I including the IOStream library in this code? So normally your comments explain why more than they explain what is being done. And then another point I'd make is that if you have really good function names and if you have really good variable names, often they can make your code so clear that you need very few comments. If you use confusing variable names, you may find yourself having to use more comments to explain what's going on. So if it becomes arduous, you're writing a lot of comments to make your code clear, maybe you need to, there's two things it could be. One, it could be that you're not using very clear variable and function names, or your code is kind of confusing and it's not very elegant. So a lot of times it may be that, okay, we need to break this up a little differently. If we structure it slightly differently, it'll be easier to read. Initially, it's going to seem like it's really difficult to get code to work. You're going to master that. In the long run, what's going to be difficult is writing code that's easy to maintain and easy for other people to understand. My ideal is that if someone can read your code from top to bottom one time, and if they're just an average programmer, they should be able to understand what your intent is and what's happening just with that one read through. If your code reads like a mystery novel and the person has to dive through back and forth and do detective work to figure out what's going on, you probably haven't written your code very clearly. So preprocessor directives. One of the preprocessor directives we've already used is the include statement, and we've used it to include IOStream. There's other libraries. CMath gives us a whole bunch of extra functions like square root, cosine. The IOmanip library, we're going to learn later, will allow us to format our output. So anything with a number sign is a preprocessor directive. What that means is it's not actually executing code at this point. It's actually a directive to the processor to do something. And so that happens at compile time. When the program runs from then on, it doesn't do that stuff anymore. So that's really things that like include this library or declare this this identifier or things of that nature. There was they often use define in the past to define a constant, as it were. It really wasn't a constant. What it was is a way of defining something that will be the same throughout. And what it was is saying, hey, wherever you see capital P and capital I, replace it with 3.14159265. Well, now we have a different construct where we use constants. And so we could define, you can put we're going to learn how to declare variables in a little bit, but we can use, well, we're going to be using this construct of using a constant instead. So there's a little bit difference in that. We'll cover that when we look at variables. The namespace standard, basically, we're going to add using namespace standard at the top, and that means we don't have to put standard : in front of all in a number of places. It's just going to make things a lot clearer. Okay, so we went through the main, we talked about curly braces, and we've done the cout. The way the cout works is cout is really representation of either console, and we have this stream operator, which is this less than sign. What that means is send whatever's on the right of it to the thing on the left. And the thing on the left here is going to be the console. So this is going to take this stream and send out console item. So here we can put out multiple lines by combining, putting multiple cout statements. So for example, here, if I wanted to, I could do this. What start at 0?
I was just thinking about the return starting at 0, similar to I guess the language Python.
Oh, okay. Yeah, this is providing a different function than that. You see down here, I have my return 0. What that's really doing is telling the operating system, which executed this function when we start running it, when it gets to the end of the program, this will tell the operating system that the program executed okay. If at any point we could write code, we could say, hey, things didn't go well, we need to stop the program. We could return 1, 2, 3, and those would be considered error codes. It's not something we use so much anymore unless you're a system administrator and you're running these from the command line. And sometimes you use those numbers to look up various error codes, or if there's another program running our program, it might use those and it might change what it does based on the error code our program runs. Since we're in a much more Windows environment these days, and this was a practice that was there back when all you had was the console. So it's a little bit different than what you're thinking of from Python. So let me show you if we wanted multiple lines, if I just did this, change this in our code to cout and make it multiple lines, I have to have a semicolon at the end of my line to designate it's the end of that line. So now I've got, how many lines do I have here that are going to be displayed?
2.
So let's give it a try.
1.
One line.
Yeah, so I'm going to make sure that this actually ran. And in some languages, this would result in 2 lines if this was like yes, exactly. So in C++, it's a fairly primitive language, so we have to tell it when we want a carriage return. And notice that it puts it on one, it put all this on one line. So how do we do that? We put a \n, and if we have that at the end, we now have it on 2 lines. Another thing you can do is rather than \n, you can also say, add another stream character and say ENDL. ENDL is basically the same thing as the \n. It'll achieve the same thing. It look up on the operating system that's on to find the correct character, whether it's \n or \r or \r and \n. It'll figure that out for you. You can use either one in Windows. And there's some different practices, and this is a matter of style, but like some people like putting their \n's at the beginning. You can see here, they put theirs at the beginning. I tend to put them at the end. It's just your preferences. C++ is a language that ignores white space. So tabs, enters, all those things, it doesn't care about. I could write this whole program like this. I'm not going to recommend you do this. I can't have a comment here, but I could do something like this. And I could say, yay, my code's all in one line of code. Well, you know, that's not really anything to brag about. I mean, it'll still run exactly the same because it ignores all the carriage returns and everything, but it makes it much harder to read when you're writing your code. So what I recommend is this. I put my curly braces on a separate line and make sure my opening and closing curly braces line up. I always tab everything in from my curly braces. I keep the statements that are at the same level all lined up. Visual Studio will kind of do that for you as you're typing. I recommend you keep that practice. The reason why you want to keep it neat is not only to make it easier for someone else to read, but it'll make it easier for you to read. And I guarantee you, you will program a lot faster if you can follow where your code is going. Sometimes we get in a hurry and think, you know what, I'll leave it kind of jagged. It doesn't matter. You know, I'll do things like, you know, this. And what happens is you're like, at some point you're trying to figure out that missing curly brace and you can't find it. So it's a lot better if you keep it neat.
Does Virtual Studio correct you if you have it all jagged?
Yeah, you can actually do this. You hit Control A, Control K, and Control F. And it will actually line it all up for you. So there's a shortcut key for that. That's Control A, Control K, and Control F. Unless it mine started jamming up. I guarantee you that actually works though. Let me write that down in the comments while my computer figures out what's going on. Control A, by the way, is select all. Control K is opens up some specialized functions, and then Control F will line everything up.
So,
Okay.
so I can do all three of those, and it'll do each, and it'll line it up whatever it needs to be.
Yeah. So
Yeah.
like what I'll demonstrate, like for example, if this is this is out of order, hit A, which selects everything. That's Control A. Control K says Control K was pressed, waiting for another chord. Control F. You notice that it pushed this curly brace back to where it needed to be and lined everything up.
Got it.
Okay, so what you want to do is you want to use your white space characters to make it easy to read. I don't recommend more than one carriage return between lines. So you can use 2 carriage returns to kind of put an extra line between blocks of code that, or pieces of code that should be spaced out. Notice that this is all in one line. It's hard to read, but if I put it like this, it's a little easier to follow what's going on. So there's a number of keywords in actually, we've been going for a little bit. Let's take about a 10-minute break, come back at 12:40, and then I'll continue on.
Mr. Gardner,
Yes.
this PowerPoint, is it also on on what is it, Blackboard?
Yes, it is. All my presentations will be, let me bring this up. If you go to learning modules, and we're in module 1 right now. And we are, let me make this, yeah. If we are currently at chapter 2, part 1.
Okay, thank you.
Okay, I'm back.
Sorry, Mr. Garner, I accidentally hit the request control button.
Oh, no worries. Yeah, actually, it's one of the nice things about Teams. If anyone has difficulty, we can you can actually share your screen, and we'll use that throughout the semester. If anyone needs help, we don't have the lab is available, but you can on Teams you can share your screen, and I can help you troubleshoot your problems. So it's kind of cool. I usually try to give a 10-minute break. Every hour or so, which usually means one, during these 2-hour sessions. I find that we need some time to kind of let things settle in sometimes. And then also it's 1 hour is a long time to sit down. Okay, C++ language has many keywords. Don't worry, I'm not going to ask you to memorize all these right now and then parrot them out in the test. That's not how we learn programming. We learn programming best by doing things. So you're going to learn most of these over the course of the semester just by solving problems with them. But keywords are basically the reason why we need to know that there are keywords is that we also will need to come up with our own identifiers for things like variables and function names. And the main thing is that we can't use a C++ keyword for variable or function name. Now, let's look at our problem before we go into this next section. We're going to need to get user input for our radius and height in our program, but we have a problem. We need to store, when we get that from the user, we need to store that somewhere in memory. And the memory we're going to use for our programs initially is random access memory. So who can tell me what RAM is? I kind of gave most of it.
Random access memory.
Yeah, and what happens with random access memory when we turn off the computer?
It
removes everything.
Yeah, you're all correct. It removes everything. So we only can we're going to learn how to declare these things called variables, and these variables are really a place to temporarily hold information while we're working with it in our program. Later on, we're going to learn how to use files, which is how we can store things to the hard drive. But this memory that we're dealing with is memory in that the computer has in RAM. So one of the things is that in order to store things, it depends on what we want to store. So we actually have kind of two different types of numbers fundamentally that we store in memory: integers and floating point numbers, and then text, which we store in the form of either single characters or strings. And so for the computer to be able to store things for us, it needs to know what we want to store in order to figure out how much memory to store for it. And in C++, we use something called a data type to do that. A data type basically is a specification that tells us how much memory to store for something. So, and there's a lot of different types. So the broad types are, for example, integer and floating point numbers, but there's different types of integers and there's different types of floating point numbers, all based on the amount of memory they take up. And then we have characters and strings. So integers are basically whole numbers, and they're all the positive whole numbers between a large positive number and a large negative number and 0. So, for example, if we want to keep track of how many cats we have, we could use integers because, hopefully you have whole intact cats that you're keeping track of. In order to declare a variable to store that information, we need a couple things, or we need 3 things. Basically, the data type, the value that we're going to store in that variable, and then a name for that variable. So here, for example, we want to store a value for radius. And so the radius, do you suppose that would be an integer type or floating point type?
That would be an integer, wouldn't it?
Well,
Yeah, floating point.
yeah, so if all cans were exactly 1 or 2 or 3 inches or centimeters, in diameter, then that would be an integer. But our value for the radius of a can will probably be like 2.3 inches or something like that. So we're going to need a floating point. And one floating point type we could use is float. So that's my type. And then we give it a name. Well, what would be a good name for this?
Radius?
Yeah, we could say radius. And so that right there is basically declaring a variable. It has not assigned a value yet, but we're basically saying we're going to store a floating point number called radius. And what C++ will do is it will allocate some space in memory to store this value. And we won't have to know the actual memory address because we're just going to refer to it with this identifier that we provided called radius. Now, one of the things that we often do is radius is good. It's pretty clear since this program only deals with a can, but sometimes we might do something like this. We will use 2 compound words to be a little bit more precise about what we are talking about. So here I'm adding the word can in front of it to say this is a radius of a can. And when we do that, we put it in something called camel case. This one's camel case in the sense that it kind of looks like a camel with a hump on it because the beginning of each compound word will start with a capital letter. If I had more words, my really cool, can radius, that would be kind of ridiculous. But that gives you an idea of camel case where we're putting we're capitalizing each subsequent compound word. Now, if you do it this way, that's called Pascal case where we capitalize the first one. By convention in C++, we start our variables with a lowercase. And so we use camel case as opposed to Pascal case. You can also start your variables with an underscore or number. You can also include underscores and numbers in your variables. Sometimes people will do something like this. And they'll use an underscore to separate their compound words. That's fine as well. I tend to like camel case. And you can also include, if you have multiples, you could include numbers. The only thing about numbers is you can't start a variable with a number. So I can't do this. That confuses it. So numbers can appear, but they cannot be the first value. Underscores and upper and lowercase characters can be the first character. So that's how we we create an identifier. This identifier is the identifier for a variable, which stores a floating point number. Does that make sense?
Yes.
Yeah.
So someone tell me what to do for the next one. How do we do height? And you can just type it into the comments if you want.
Is it float can height?
Yeah. That we provide the type and then an identifier. And you can get to choose what this is, but the other thing I like to do is I like to try to stay consistent. Like I wouldn't do this, for example. I find that would create some cognitive dissonance in someone who's reading this. Consistency will make you faster, and actually using good variable names will actually make you figure out the problem better too. It's surprising. I've seen people misname something and it completely confused their solution. You just rename the variable and suddenly, oh, the solution just jumps out. Okay, so floating point types can have a decimal value. So, with pizza. Here we have a quarter of pizza. They have 1/8 of a pizza. So, and then we also have another type called Boolean, which can store basically the values true and false. For character types, we have a char, which can only store one character, and the char stores the values for let's see. If you go to ASCIItable.com, this table actually shows you the decimal number. Now there's hex and octal numbers here, but for now, just look at the decimal number and you'll notice that, for example, capital A is 65. So let me find 65. Yep, 65 is capital A. Lowercase a is 97, and the space character is 32. And you'll notice that they increment. So actually, the characters you have on the keyboard all have a number associated with them. And also, a lot of characters which are invisible, like your backslash, your new line, /n is actually ASCII code 10. That's line feed. Tab is ASCII code 9. That's actually a /T also in that nomenclature. And all your special characters have numbers. Those, that's actually how they stored numbers back before Unicode became a thing. Unicode was introduced because, well, everyone in the world's using computers and we've got to represent their character sets. So if you can go here and see what the different character sets are, and they have their own numbers that represent their characters. So that Unicode, so since C++ defaults to UTF, use the ASCII table, and the characters are represented as a number between 0 and 127. And a char is actually a number that can represent a value between 0 and 256 because it's an 8-bit number. There's some tables in your, and so in point of fact, actually char is a numeric type and it's an integral type. It's an integer because, you know, each character has its own distinct number. And so char is an 8-bit integer type. Int is actually 16-bit integer type. And then you have your float and double, which are your floating point types. A float can represent about 6 or 7 digits of precision, and a double can have 13 or 14 digits of precision. And it's basically because of the number of bits that are the amount of memory that's used. So how much memory would I need to store a floating point number with an infinite amount of precision? An infinite amount of memory, absolutely, Wyatt. So it's not practical to have an infinite amount of precision in a floating point number. Every time you store a floating point number in a computer, you are truncating it at some level of precision in order to make it practical to store that number. That means your floating point numbers are not necessarily always precise. There's also a void type. Void is different than 0. Void is actually the absence of value. And that's a very important concept in programming and data. Is there's not just 0, you know, a value of 0. There's also the idea that we don't have an actual value. And then we have bool, which is Boolean, which is true or false. And then a W char is a Y char. That's actually Unicode. And that, rather than 8 bits to represent characters, it's 16 bits. 16 bits is enough to represent all the character sets in the world. And so if we wanted to use Unicode, we would use wchar in C++. Also, with our data types in C++, we have some modifiers we can apply. So we can apply the word short, long, or unsigned. And for example, a short int would have half the memory as a long int, and an unsigned int would be able to store, for example, an unsigned int would be able to store the values between 0 and 65,000 about. I think it's 65,536. A signed int or a regular int would be able to store from minus 32,000 to positive 32,000. So half the magnitude, but also would have positive and negative. And that's because a signed number uses one of the bits to represent positive or negative. Okay, so all the types in the magnitude of all the types in memory actually are all going to be multiples of 2, or 2 to some power. And that's because everything in a computer is stored as bits. Bits can represent 1 or 0. That means 2 separate values. So any multiple group of bits that's being used to store information will always be some magnitude of 2. And so a 16-bit number would be 2 to the 16th power, which would allow you to store 65,536 combinations. That's why you always see these numbers show up all the time. 256, 512, 65,536. Well, if you do any kind of machine code or assembly language, you end up like memorizing those values. But and this chart here shows you how binary works. So if I have just one bit, which can represent 0, 1, I can have up to 2 values or 2 combinations. If I have 2 bits, I have 0, 0, 0, 1. Then I can have 1, 0, and 1, 1. So that gives me 4 combinations. If I have 3 bits, that gives me up to 8 combinations. And a byte, which is a standard element in programming, is 8 bits. So normally most memory is addressed at least at 8 bytes. And so 256 combinations are represented by 8 bytes. You don't need to know this in great detail at a language at C++ level or higher, but you will see these values show up over and over again because of this. Now, this is a chart that shows you the magnitudes for different types. So, for example, a char can represent from minus 128 to 127, an unsigned char from 0 to 256. An int, which is a common one, minus 2 trillion or 2 billion, I think, to positive 2 billion. So quite a lot of numbers. A short int can represent that. So, you can actually, if you're Amazon, you'd think that an int can represent most of what you need for integer numbers. But if you're Amazon, you might have actually more users than that. So you may need to use something like a long, actually an int and a long int, I think, are the same. So you may need to have something larger than that to represent all your user indices. And then we have different types of floating point numbers. A float, and then a double and a long double. Most of the time, you're going to be using integer, floats, and doubles. So why do we need to pay attention to our types? Well, on June 4th, an unmanned Ariane rocket was launched by the European Space Agency and exploded 40 seconds later. And the reason was that a 64-bit floating point number relating to horizontal velocity was converted to a 16-bit signed integer. Well, what happens is, as long as the number of significant digits is less than 16 bits, it's fine. But as soon as the number was larger than 32,000, which exceeds, 16 bits, what happened is when the conversion happened, it truncated the excess value. And in doing so, it actually converted it from a positive number to a negative number. So here you are going at Mach, 30 in one direction, and suddenly the computer thinks that you're going in Mach 30 the opposite direction. What's it going to do?
It's gonna try to correct its course, right?
Yep, it tried to turn at Mach 30, 180 degrees. And that happened, and that, I'm going to stop sharing and start sharing again because I need to enable sound. Let's see, I thought this would play. Okay, I don't have the video. I might play it next time. But basically what happened is that's exactly what happened. The Ariane rocket actually turned 90 degrees and just explodes. So kind of important to be able to do that. So I'm going to give you since we're coming towards the end of our time here, I want to give you enough that you might be able to get a little start on the program that's coming up. And so here in our program, we declare two variables. Well, how do we get input into those variables? The opposite of cout is cin. We then use a streaming character that says basically cin represents the keyboard. We're going to take from the keyboard and put into radius, and then down here we're going to cin and put this into can height. And then the thing is, though, is if I just do that and I run that, I mean, it works, but it's kind of confusing to the user, isn't it? What do we need here to make it not be confusing to the user?
Output questions to answer?
Yes, we need to tell the user what we want, and we do that using basically the same thing as we did here. We say, please enter radius of can. And you also want to specify the units. Now, when I put out my prompts, I don't put a carriage return because I just want them to type right after my prompts. And then I'm going to do the same thing here for my notice I make a change to the program, and then I run my program. And I can see that gives me inputs. And then, okay, so now I want to figure out the area of the circle. So again, I want to store the area of the circle in a variable. What type would I make this area?
Float.
Yeah, so float area of circle. And we're going to get into this more later on. I'm giving you a preview because it'll get you started a little bit faster. But I can then say area of circle is equal to, and now we can do math with these variables I saw. What's the formula for area of a circle? Does anyone know?
Is it just height times width, or the height times the radius?
No,
I don't know.
Yeah, so if you haven't seen that in a while, and it's not unusual in this course, we've been a while out of our math, that's okay. Let me know, and I'll point you in directions to catch up on that. But it's a pi r square. So we need the value of pi, which I'm just gonna put 3.14 for now, times. Now the symbols in programming, asterisk is multiplication. A slash is division, and then you have plus and minus. Plus is addition, and minus is subtraction. So we can do 3.14 times, and it's going to be pi r squared. So can radius, and I'm just going to do that twice for now. We'll learn a lot better way of doing it later. And I could go and figure the rest of this out, but I'm going to just put down here C out and temporarily just say radius is, and then I can put another stream character and put in my variable area of circle. And then I can put in the units. So what will be the, if I input the radius in centimeters, what will be the area's units?
Centimeters squared.
And then I'll put an end line because I want a carriage return there. So you notice I'm not doing the whole thing. I'm not doing all this. I'm just doing, well, let me just figure out the area first. And so I'll put 5, I'll put 7, 78 centimeters squared. So now I could go calculate that. You know, if I put 5 times 5 is 25 times 3, that looks about right. I would actually want to calculate that. The other way you can test this is put something that's easy to calculate. If I put 1 in here, I should get 3.14 because 1 squared, 1 times 1 is 1, times 3.14 is 3.14. And yeah, so it looks like it's functioning properly. So that's one iteration through this program. And then the next iteration would be, I would calculate the area of the sides and maybe display that. And then I would figure out the total area and then display that. And then I might hide the radius and the area of sides because I really just wanted that one last thing. And that's kind of a way of going through the program. So we've learned now how to output text, how to input a number with cin, how to store that in a variable. Notice that we have to have a variable whenever we do input, how to output a prompt, which is really just the same thing as cout, how to do basic math, and then how to display results. And so let me take this. I'm going to put this in the text so that if anyone needs to refer back to it, it's there in Teams. Does that make sense? Kind of how, you know, this is a basic fundamental way of making a program.
Yes.
Yes, sir.
Cool. So let's look. I'm going to show the first program, and it's due a little. It's due. I think well after. But that should be able to get you started. I'm going to also recommend that you run through this variable demo exercise and then this operators demo exercise. So read chapter 1 and 2 and go through these 2 exercises. There's video recordings of them. And we'll go through this in more detail later, but I'll talk about it very quickly. You're going to be doing a similar program here, where part of it will actually be figuring out the area of a cylinder. And so you're going to do very similar to what we're doing right now, but also you're going to figure out how many cylindrical objects could be stored in it, given the radius of those cylindrical objects. And so what you're going to do is you're given the formula here to calculate out how the area of those, and then let's see. You calculate the volume of the jar that it's going into. You calculate the volume of the cylinder, and then of the spheres. And then let's see. Yeah, ask for the dimensions of the jar. Ask for the, and then there's a, and then let's see, what is the packing factor? Okay, so we know that we can't just take the volume, inside volume of the jar and divide it by the area of each of the beans, because they won't fit in 100% of the space. So we're going to estimate that 20% of the volume will not be filled by the cylinders inside of there. So given that, you're going to have to factor in that space that's not in there. And so that will be, and then let's see, are they, assuming these are spherical or? Yeah, so they're not assuming they're assuming it's circular in one direction and then an ellipsoid in the other direction. So we will have for the volume of a bean, we'll have, it's an ellipsoid. So we'll have the length, the A diameter for the bean and the B, and this, all you have to do is just ask the user for A and B, and this will give you the volume of that bean. So between the internal volume for the jar and the volume of that each bean, you'll subtract 20% of the volume of the jar to get the usable volume, divide that by the volume of one bean, and that'll tell you how many will be able to be stored in that jar. So you're going to make a program where you're going to ask for those factors, do the calculations, and display the results. Notice how I made this program by first starting out by writing out the things I need to do. So what you could do is do the math problem first by hand during this upcoming break. Maybe even start getting the inputs that you're going to need, get the inputs, and then you could even just start calculating some of the aspects. Get the volume of the jar, get the volume of the bean, and then you can start working on the other more complex piece. Make sense?
Yes, sir.
Yes.
Yeah.
So I think I got you started for in good position for the break. We will see you all next time. Not Monday, but the Wednesday.
Have a good weekend.
You too.
Oh, so we're not meeting on what's Labor Day, right? So we're not
Right.
meeting
Yeah. That's why I wanted to kind of push a little bit and get a little bit more in there. Hopefully, you might be able to get into that program a little bit. But try to do those two tutorials. They'll get you started pretty well too.
All right. Thank you, Mr. Gardner.
Absolutely. Thank you.
I have a couple of questions.
Sure.
So P1 is due when?
P1 will be due. I think we have a couple weeks for it. Let me see. Where is it?
When is that?
P1 is due on the 14th.
Okay.
Yeah, so you got another weekend too between now and when that's due.
And my other question was, so do we save it how do we turn these in? Are we going to discuss that maybe next time?
Yeah, we'll discuss that next time.
Okay, right on.
And I might have everyone like on the 14th. I'll walk I'll walk everyone through that again just to make sure if anyone needs it.
I have a couple questions. Oh.
Okay. Thank you.
I have a question.
Yes.
The P1 project is the Jelly Bean project, correct? I just want to clarify that.
Yes.
Okay, and then we can find that in our
And the learning
assignments?
modules, almost everything is going to be in learning modules here. And so we're in module 1, program 1, and you'll find program 1 here. Also, I'll have to go over this next time a little bit more, but there are test cases in this, I think. Where did she put the test cases? I'll go over the test cases next time.
Next Wednesday? Okay, perfect.
Yep.
Thank you.
Sure.
So I do have a couple questions as well.
Yes.
So aside from getting sorry, I'm having trouble finding the words here. So
No worries.
aside from P1, are there any other assignments you're expecting us to turn in anytime soon?
I'm recommending that you do, I think everything's due on when the program's due, but I recommend that in module 1, go during this break, do the declaration demo exercise and the operator's demo exercise and turn those in.
I also sent you an email about this, but since talking now, I figured I might as well bring I'm getting I have an appointment with the DRC to get an accommodation written up for the semester.
Okay.
It's not going to be for like another week, so I can get that to you. All right.
Yeah, that's fine. If there's anything I need to do for you between now and then, let me know. And when you get that, we can meet on a private Teams chat and discuss anything if it's not pretty obvious. If it's a standard accommodation, I don't think we'll have any issues or difficulties.
Cool. Thank you.
Sure.
I have another question.
Sure.
The examples we did today, do we have to save those or can we?
No, that you don't have to save those. These demos in are the variable declaration demo and operators demo. Those are the ones that you'll have to do on your own and turn
Save
in.
and turn in?
Yeah. So
Okay,
follow.
but these are just examples, right?
Yeah, these are just examples. And normally I would be like on a whiteboard, doing this stuff. So that's how I whiteboard, is I just write the code there and invite you to follow along, so that you can actually do the code while you're listening to me talk. It's a little bit more active that way.
Okay.
Hey, so I have a MacBook Pro.
Yes.
And it has the touch bar, which means I don't have
control
keys. Yeah, like the escape key. I noticed I was lacking yesterday when I was trying to do some Linux homework. And so I'm wondering, do I need like a normal, or
I don't think so. Let me see if we can find it. I don't have a Mac myself, so I'm not familiar with all those key issues. So let's see, Mac, escape key, Visual Studio. Are you running Visual Studio in Boot Camp?
So I haven't been able to install a boot camp yet because I don't have enough space on my computer.
Oh, okay.
So I was waiting to ask you like if I like needed to get a like Windows computer instead of like an external drive. So yeah.
Okay, so you can use, I think, the virtual machines. I'm not sure what you would need. Well, let's see. MacBook Pro and later feature the touch bar, which changes automatically based on the application you're using. Let's see. So here's something. MacBook Pro 15-inch 2016 and later feature the touch bar, which changes automatically based on the application you're using to show you relevant familiar tools and controls. On some models, the escape button appears on the left side of the touch bar, and the same place the physical escape appears on traditional keyboards. Sometimes tools in the touch bar temporarily cover the escape button. After you tap the plus or done button, the escape reappears. Is that helpful?
Yes, that is. Okay,
Let me
cool.
let me give you this link. I'll put it in the chat.
Okay, cool.
Yeah, I'm pretty sure that you can. There's so many people that use Macs that I think there's a solution for almost everything. So, now can you? Are you going to free up some space and try to put Boot Camp on, or do you just want to use the VDI?
Yeah, well, so I'm going to I'll go get an external drive today.
Okay.
Yeah.
Got it.
Yeah, and also, did you get my email about my mom? I'll try to get into the class.
Yes. Does she need a override still?
So it said that like the deadline for like signing up for the class had passed. So
okay, I need to give her a late registration. I can do that. Let me see. Let's see. What's the name again? What was your name again?
Oh, Sean Poitras.
Let me see if I can do that real quick.
Cool.
I usually am inundated at the early part here.
No worries.
Let's see. Did you send me her student number?
Yes. Yeah.
Okay. That's good. And is there another? Someone else have a question while I'm working this? Okay. I hear someone, I think, speaking, but it's coming in low and kind of broken. Let's see, overrides. Okay, she should be able to register now. I just put it in.
Sweet. Thank you.
Thank you.
I have another question.
Sure.
So when you run the in visual, because this is my first time programming. When you run the item, do you debug it and then run, or how do you run the program?
So right here, can you see my screen still?
Yes.
So up here under debug, there's two options: start debugging and start without debugging. We're going to initially use start without debugging, and the shortcut key to that is Control F5. So what I recommend is you can click here and it will actually start without debugging, but I recommend that you look at the shortcut key, close the menu, and then hit Control F5, and then it runs. Now, what will happen is you come back to it, you don't remember, go ahead and go to debug, look at the shortcut key again, and then hit Control F5. After a while, you will not have to go look at that menu because you'll just start remembering it. And that's a way of memorizing keyboard shortcuts. And now you can do that with any application. So like if you're trying to memorize shortcut keys for Word or whatever, I will typically do that. And eventually I have a bunch of shortcut keys I remember that way.
Okay.
So
and
Control
then just run the
F5.
program. Okay. That's all I want to know. Thank you.
Cool.